Hi! The VERA RUBIN Observatory recently released the first set of images taken during the test run of the giant telescope. In this episode, we will discuss what those images show, why is the VRO significant, and how does it compare to its predecessors, including the recently functional James Webb Space Telescope. So without any further ado, let's begin. Proposed in the year 2001, this giant machine was initially called the Large Synoptic Survey Telescope, or LSST. Located on Mount Cerro Pasho in northern Chile, the 8.4-meter telescope is jointly funded by the U.S. National Science Foundation and the U.S. Department of Energy Office of Science. Built with a cost of approximately $473 million over 2 decades, the VERA RUBIN Observatory offers an unprecedented view of the universe like never before. Besides a very modern design, VRO's USP is the 3200 megapixel camera installed on it. This state-of-the-art digital camera has 67 times more pixels than the camera on an iPhone 16 Pro, which, together with its large mirrors and unique design, allows the giant telescope to capture very wide-angle images. In fact, each image captured by the VERA RUBIN Observatory is 3.5 degrees in diameter, which is equivalent to the size of 7 full moons in the sky. This unique feature will allow VRO to image the entire southern hemisphere sky in just 3 nights, and it will continue to do so for the next 10 years. The data thus collected will lead to a very high-definition, wide-angle astronomical time-lapse video of the sky, bringing the sky to life, literally. These data will allow astronomers to study changes happening in the sky over different time periods from a few minutes to several years. While its predecessors, such as the Hubble Space Telescope and the James Webb Space Telescope, have higher resolution, it is the ability to capture a large part of the sky in a single image which sets apart VRO from the existing observing facilities on the ground and in space. Since the VRO will scan the sky continuously, astronomers will get a pretty good idea of how a particular part of the sky generally looks. This will allow them to pick out any changes from the previous week's images or previous month's images and eventually images taken a few years ago. In fact, the state-of-the-art software technology developed for the VERA RUBIN Observatory allows it to compare each image to the general image of that part of the sky within 60 seconds and send out an alert if any changes are detected. When fully operational, the VRO will generate around 10 million alerts every night. There is news for those interested in big data and data analysis as well. The VRO will collect 20 terabytes of raw data every night. That is equivalent to more than 3 years of streaming videos or 10 years of streaming music. Taking around 200,000 images every year, the VERA RUBIN Observatory will eventually build up 120 petabytes of data over its survey period of 10 years. The VRO is ready for the known unknowns and the unknown unknowns, but it was constructed to meet 4 specific science goals which are listed here. We know that 80% of all matter in the universe is dark matter. This was discussed in details in our earlier video, a link to which is provided in the description below. In fact, the telescope was renamed as the VERA C RUBIN Observatory in 2022 to honor the American astronomer VERA RUBIN, whose research was at the forefront to show the signs of dark matter. RUBIN studied galaxies and in particular their rotation curves. A rotation curve is the distribution of velocity of stars in a galaxy as a function of their distance from the center. Assuming that most of the matter in a spiral galaxy is concentrated at its center, the rotation curve should decline at larger radius. This is what we observe, for instance, in case of Keplerian motion for the planets in the solar system. However, Rubin and her colleagues found that the rotation curve for spiral galaxies were either flat or rose higher at larger radius. This therefore implied that spirals composed of some matter other than the stars and gas, which held them together and was responsible for the observed rotation curves. This was the first evidence in support of dark matter. But despite her significant contributions to the field of galaxies and being a front runner for the recognition, Rubin was denied the Nobel Prize due to gender bias, as is popularly believed. But the VERA RUBIN Observatory is now ready to pay true tribute to Rubin and her colleagues by observing billions of galaxies and advancing our knowledge of dark matter and dark energy as part of the Large Survey of Space and Time, or LSST, which is so named to preserve the acronym for the name of the telescope when it was proposed. Since the astronomers will study the changes in the sky, it will allow them to discover several new fast-moving objects such as comets in the solar system using VRO's data. The VERA RUBIN Observatory will also play a crucial role in the discovery of new asteroids. Even though 1.5 million asteroids are known, scientists estimate that we have seen only about 30% of those smaller than 140 meters in size. VRO will change this to 90%, finding new small but potentially hazardous asteroids, especially those like YR4, which are on a collisional course with Earth. VRO is estimated to increase the number of known objects in the solar system by 10-folds and find the 9th planet, if it exists, within the first year of its operations. It may also find new dwarf planets like Pluto and small faint satellites of other planets. All galaxies started as small clumps of dark matter, gas, and stars in the early universe. These halos were pulled together by gravity to form bigger and bigger galaxies. This means that all large galaxies like the Milky Way have been forming through a series of hundreds of these mergers for over 10 billion years. Some of these mergers happened so long ago that their traces are mostly lost. But some were big enough or so recent that we can actually look for the remnants they left behind. Let's look at the Milky Way, for instance, and imagine that it has a smaller companion galaxy orbiting it. But the companion galaxy doesn't have enough energy and momentum to keep moving around the Milky Way. Gravity is pulling the Milky Way and the companion closer together, and the two are destined to collide and merge. As the companion galaxy falls onto the Milky Way, the gravity of the Milky Way is so strong that it actually tears apart the companion galaxy. The companion stars get pulled out into streams that can sometimes be so long as to wrap entirely around the Milky Way. So the companion galaxy no longer exists as a single object that we can observe, but its stars will continue to form these streams for a long time. By studying how many stars there are, the width of the streams, the paths the stream follows, and the properties of the stars themselves, astronomers can figure out how big the companion galaxy was, when it formed, and what path it took around the Milky Way. Astronomers can also use these stellar streams to reconstruct the formation history of our galaxy. So far, we have found 23 streams around the Milky Way, but we think there might be many more. Light from what used to be a galaxy is now spread out into these thin streams instead of being concentrated in one spot. So these streams can be extremely faint and cover a large area on the sky. The VERA RUBIN Observatory will be a very powerful tool to help astronomers identify and observe these streams because it will image the entire southern hemisphere sky more deeply than ever before. Astronomers will therefore use the Rubin data to help tell the story of our own galaxy better than ever and map the history of the Milky Way like never before. But stars evolve over time. In fact, some stars, known as variable stars, can visibly change on short time scales of a few minutes to few years. Stars change their brightness for various reasons. For example, supernovae are massive stars which violently explode before nuclear fusion stops in their core. During the explosion, supernovae can brighten up for a few days and are luminous enough to be seen by naked eyes. Others, like Cepheid variables, have their outer surface pulsating in and out due to changing pressure within. Besides these usual changes in the night sky, VRO will also be able to detect unusual events such as merger of two neutron stars or stars being torn apart by a black hole in their vicinity or even supermassive black holes eating nearby gas in their galaxies. I am extremely excited at the prospects of discovering things we could observe with the VRO but could not identify. The first light images created using a few nights of data which were released by the observatory on June 23rd already look very promising. The image here shows a part of the Virgo galaxy cluster, the nearest cluster of galaxies to Earth located at a distance of around 53 million light years. The image shows a whole suite of galaxies, grand design spirals, old ellipticals, and interacting galaxy pairs all bound together by gravity. It also shows groups of galaxies in the background clearly identified by their reddish hues and close proximity on the sky. Another set of data shows several asteroids moving through the sky. In fact, VRO has identified over 2,100 new asteroids in a week, while all other observing facilities put together find around 20,000 asteroids in a year. It is mind-boggling to think that most of the objects seen by VRO do not yet have a name or identification because they have never been observed before. This colorful image from the VRO shows swirls of gas and dust in the Lagoon and Cepheid nebula, star-forming regions buzzing with new star formation in our galaxy. Such unprecedented details of these stellar nurseries will help astronomers learn more about formation and evolution of stars. It won't be wrong to say that the giant VRO images are a snapshot in space and time, capturing the Milky Way stars in the foreground, clusters of galaxies such as Virgo nearby, and galaxies moving away from us with the flow of the expanding universe in the background. I hope you enjoyed this discussion on the swanky new observing facilities which is ready to open the doors of the universe for us like never before. In fact, you can scroll the details of the images released by the observatory using the Skyview app, a link to which is provided in the description below. What did you find most fascinating about the VERA RUBIN Observatory or the data it's taking? Do let me know in the comments below. And if you enjoy our videos, please do share our content with other astronomy enthusiasts and don't forget to like, share and subscribe to our channel. I'll see you next week. Until then, take care.